systematic risk and non-systematic risk, or how I like to call it, good risk and bad risk. So let's say this is your total risk and you have one stock. You've only invested in one stock, and this is the level of risk that you have taken. Now, as you increase the number of stocks that you have got, right, what happens is your risk starts going down and down and down and down, and then it kind of just stabilizes. So what has really happened? What's happened is that there was a lot of risk inside your total risk, which was not good risk. It was bad risk. And now what you are left with only is what is good risk. Now there are lots of names for the good risk. The most appropriate name for it is the systematic risk. And the most appropriate name for your bad risk is non-systematic risk. But what are the other names? This is called also diversifiable risk, right? Because you can diversify it away by diversifying your portfolio, right? It is also called aka idiosyncratic risk. And what does that mean? So idiosyncratic risk means risk which is specific to some company, right? So let's say you had invested only in this one stock, and that one stock is highly dependent on its CEO, because the CEO is this major figure, and God forbid something happens to that CEO, right? So I mean that is a very, very company specific risk, right? Also called aka company specific risk, that you can diversify away, because it's possible to buy more than one stocks, right? And why is that bad? It's bad because you don't get any return for taking this risk. So what we have been saying so far is that, hey, risk measured with standard deviation, and the higher risk you take, the higher return you get. Well, that's not really true. And if you remember, there were lots of different portfolios, but many of those portfolios we didn't say were optimum. Of course, yeah, we still stand by our point on the market portfolio being optimal. And that's because the market portfolio has only systematic risk in it. Because when we say market, and think about it, right? I mean, if you're using the S&P 500, well, 500 is much more than 30, right? I mean, if beyond 30 stocks, your non-systematic risk is completely diversified away, so then what do you think is going to be the situation at that 500 stock mark? So why we still stand by our claim that the market portfolio is the best portfolio? The reason for that is that the risk that is inside the market portfolio is only systematic risk. And that's what we're going to now talk about, that how do you then say that how much a particular portfolio or a particular stock, how much good risk is it inside there and how much bad, so that we are able to differentiate the two and then optimize our taking of the good risk so that we can get return for every good risk that we're taking. Right? So that's basically what we're going to now talk about. You might be feeling a little bit confused, but as you go through this video, hopefully everything should be a lot more clearer for you. Right. So obviously to get high returns, you need to take high risk. But does all high risk lead to high returns? The answer is no. You have to take systematic risk, right? And you don't need to take non-systematic risk. So total risk is measured by standard deviation, right? But what we want is to somehow single out that systematic risk part and have a tool to measure it, which very soon you will see we call beta. And that is what is something we will figure out through the market, because as I was telling you, that it's the market portfolio that has pure systematic risk in it. So to understand what beta is, we really need to start at that market risk and return, that what is the market risk and return, and then based on that we're going to figure out everything else. Because the other part of the risk is absolutely useless for us. It's idiosyncratic, right? Which another way of saying it is that it is local and can and should be diversified away. Because you as an investor are only going to get return for taking systematic risk. By the way, another very important name for systematic risk is your AKA macroeconomic risk. Market risk, macroeconomic risk. So market risk. And what does that mean? It means that what you get compensated for is taking on that macroeconomic risk, not taking on company specific idiosyncratic risk. And what are macroeconomic factors? Inflation, interest rate, exchange rates. So those are the type of risks if you take, you get the return. And that is called market risk, also called undiversifiable risk. Right. So this is what affects the entire economy. It cannot be diversified away. And now we're going to learn how to price this risk. And what's really going to change is that instead of putting standard deviation on the x-axis, we're going to start putting beta. And then we're going to say, oh wow, this beta is this wonderful thing that as you increase it, your return just goes up. Not like with standard deviation that the return is going up but in a smaller and smaller way. It wasn't a 45-degree line. Your efficient frontier, when made on the standard deviation, is kind of like sloping, and then it's becoming lower and lower and lower. That for every additional amount of risk you're taking, the return is not going up. Unless you talk about the capital market line, and yes, that is a very special case where you are having the market portfolio, and of course the market portfolio only has systematic risk in it, and that's why the capital market line is so special, right? But if you really want to get rid of this entire situation, then you could just make your x-axis instead of standard deviation come to beta, and we're going to talk about that shortly. Right, now if I tell you that the market is having a risk of 18%, right, in terms of standard deviation because it's total risk, and the 6-month treasury bill has no risk, obviously, right, because their standard deviation is 0. How would you describe the systematic and non-systematic risk components? Right, so how much systematic risk is there in a treasury bill, how much non-systematic risk is there, and how much systematic and non-systematic risk is there in the S&P 5. Pause the video, think about it in your mind, and then check the answer. Right, you're absolutely correct that there is 0 systematic and 0 non-systematic in the treasury bill because, well, there's just 0 risk in there. And as far as the S&P 500 is concerned, there's only systematic risk. So all 18 of that is actually systematic because it is the market. There is 0 or no non-systematic risk in there. Now, 2 assets, X and Y. X has total risk of 25, of which 15 is systematic, whereas Y has, well, it's an S&P 500 index fund, which means all of its risk is systematic. Now, which one do you think is going to have a higher return? Given that you know that systematic risk is what gets you high return. Taking unsystematic risk does not. So which one do you think will have a higher return, X or Y? Yes, you're absolutely right. Y is going to be the one which will have a higher return because the systematic risk it is taking is more than X, right? X, the systematic risk is only 15%. Even though the total risk is higher, but we don't care about that. We only care about the systematic risk. Now, this brings us to the capital asset pricing model, which basically says the return that you should get on a stock should be obviously more than the risk-free rate. Otherwise, I'll just put my money in the bank. Why should I take a risk? But then how much more should it be more than the risk-free rate? Well, at least as much as the return on the market, right? that as much as the market pays me over and above the risk-free rate, but the market has a beta of 1, right? If I'm investing in a stock which has a higher beta, let's say a beta of 1.5, then I should get 1.5 times that market risk premium, right? Over and above the risk-free rate. So this is your capital asset pricing model, which is obviously a single factor model because we're only having one factor here, which is beta. You also have multiple factor models, which we will look at shortly. But let us first talk in more detail about this single factor model, which is the beta. Now, it is, of course, kind of the slope. Well, not kind of, it is the slope of this line. But I want to remind you of something that we talked about in linear regression, and also something we talked about in our quantitative material, where we said that if you have x and y and you want to know the correlation between them, right? So the correlation between x and y is the covariance divided by the standard deviation of x divided by the standard deviation of y. Now, beta is not the correlation, even though it seems very similar that you're taking. So let's say if x is your market return and y is your stock, the one that you need to know how much beta is inside, how much systematic risk is inside this particular stock. Is it 1, which means it's the same as the market, or more or less than 1? You're taking the covariance between the stock and the market returns, but instead of dividing it by the standard deviation of x and standard deviation of y, you're just dividing it by the variance of x. Now, why are we doing that? Because we want to make the market the base, and we want to see that if this is a representative of systematic risk, then we want to see, okay, how much systematic risk is inside this particular stock. So how does it move with the market versus how does the market move by itself? So essentially what you're getting over here is that for every movement in the market only, what is the movement of this particular security? And this is different from correlation, right? This is different from correlation because in correlation, we would take both standard deviation of x and y, and they both are useful. Correlation is also useful when you want to know the relationship between x and y, if it is perfectly positive or perfectly negative or whatever. And that's a really useful concept when you're doing your portfolio diversification, and we've talked about the importance of correlation. But here we're applying a different concept. We're talking about the market being this very special security asset that tells us what is the embodiment of systematic risk, right? And then we really need to put that in the base and then check anything, any asset, how its return changes with the market. And that would then tell us how much systematic risk is there in a particular security. And what do we do then with that? So let's say the standard deviation of the market is 20%, right? Now, how would you know that how much beta is there inside a given portfolio? So if you've got a 6-month T-bill, a commodity with this much standard deviation, 0 correlation with the market, and a stock with this much standard deviation and a 0.6 correlation with the market. So what is the beta for this entire situation? Well, obviously for the 6-month T-bill, the beta will be 0 because it's not going to have any correlation with the market. For the commodity, again, the beta is 0 because if the correlation with the market is 0, well then the same situation is going to be there for it, that there is no systematic risk inside this. However, now, when you talk about this stock, clearly there is some systematic risk there because it is having a certain correlation. Now you know that correlation is equal to covariance divided by the two standard deviation. Standard deviation of the stock, standard deviation of the market, covariance between the stock and the market. And if this correlation you know is 0.6, covariance is what we have to calculate, right? No, actually what we have to calculate is beta, which is the covariance divided by the variance of the market, right? So we don't know the covariance But we do know that the stock has a standard deviation of 0.25. So we can write that over here. And if I assume that whatever the standard deviation of the market is, which over here they've told us is 20%, but regardless of whatever that is going to be, it's going to get cancelled out. But I'll come to that later. For now, what I am basically saying is that this covariance, let's say I didn't know what the standard deviation of the market was, but I could put the 0.25, which is the standard deviation of the stock, over here, right? I could put this 0.25 over here because I do know that. And if I take the standard deviation of the market on the other side, so what I've basically got is 0.6 into standard deviation of the market is equal to the covariance over 0.25, right? And if I want to calculate beta, which is covariance over the standard deviation of the market, now I know that the covariance, if I make the covariance the subject of the equation, it would become 0.6 into standard deviation of the market multiplied by 0.25. And then if I plug this entire thing over here in terms of the covariance, so I could say beta is equal to covariance, which then becomes this thing, which is 0.6 into standard deviation of the market into 0.25 divided by the standard deviation of the market squared. So standard deviation of the market, standard deviation of the market. And this would then cancel out with this. And what I have left out is 0.6 into 0.25 divided by the standard deviation of the market. Now, of course, I mean, if I need to solve for beta, I do need to plug in the standard deviation of the market, which you can see is here. But I just wanted to explain to you that how it's cancelling out in terms of the standard deviation of the market being in the numerator and the denominator as well. So I don't think you're going to get this type of a question in your exam. It's just unusually long. But I mean, it's just useful to understand exactly what are all the different moving parts. Now, guys, let's take a break and then we'll come back and discuss the capital asset pricing model in a bit more detail.